So yeah, this is going to be a quiz. So if you're not on the Wi-Fi, get yourself on the Wi-Fi now. The username and password is on there. And then once you've done that, if you want to go to this URL and make up your own username and password. So yeah, obviously not the same username and password, or a bunch of you will be on the same account. So yeah, you won't be able to get to that URL if you're not on that Wi-Fi network. So make sure you are. And if you're watching this on the live stream, tough luck, I'm afraid. You've just got to play along using your brain, and you can write things down on paper and score yourself if you want. So the reason I'm asking you for a username and password is just so you can switch devices halfway through in case your phone starts running out of battery and you want to switch to your laptop. Just use the same username and password and everything will work. The password is stored in plain text on my machine, so don't use like your credit card number or anything like that unless you are intending to make a donation, and that will be gratefully received. Thank you very much. So I'm going to assume everyone's ready to go. I will keep the URL in the corner of the screen, so if anyone loses it, you'll be able to pick it back up. I kind of hacked this together on a plane. You could probably break it by trying to break it, so please don't try and break it. I've made it so little Bobby tables can play. That's not going to break it. But there are probably other things you could probably DOS it, so please don't do that. And I want to stress that this quiz is pretty tough. I've seen it get the better of people who do this kind of study of browser quirks for a living. So if you're the kind of person who gets really angry and starts flipping over tables when you don't win, then just maybe stay away from the tables for a little while. Okay. Of course, what kind of quiz would be complete without a prize? So, the Chromebook Pixel is Google's latest laptop, featuring an i5 1.8 GHz dual-core processor, 4 GB of RAM, and a touchscreen with a higher DPI than a MacBook Pro. Couldn't get hold of one of those, sorry, they wouldn't let me. But what I did get is a Chromecast, so I've got one of those to give away for whoever gets the highest score. So it's not quite a Pixel, but it's very, very good. So let's start off really simple. So the URL's there in the bottom of the screen if you need it again. But here's a nice, easy start. You've all worked with images in HTML, right? Okay. So here's a div, but it has a source like an image might. Which browsers do you think are going to make a request for that image? Now, on your phones or on your laptops, you should be presented with the options. So you pick which ones you think are going to make a request and then hit submit. If it's not appearing on the screen or the icons aren't, you can just give the page a refresh and that should come through. When we're talking about these browsers, I mean the latest versions of each one, so IE 10, etc., etc. You get 1 point if you get it right for a particular browser. You lose a point if you get it wrong for a particular browser. So there's a maximum of 4 points per question and a minimum of -4. You can score negatively. You can assume the HTML5 doc type, and there's nothing hidden going on. I'm not going to turn around and say, oh, but there's a base element that's changing the URLs. There'll be none of that. It's just what's there on the screen, that one line. So what we're seeing here is like a live opinion of the room as well. So the needle swings one way when you're saying collectively that yes, the browser will make a request. It will swing the other way if you're saying no. But I'm going to randomize which way is yes and no for each question, so you can't just look at the screen and vote along with the room. Okay, so that's probably enough time. I'm going to close the question in 3, 2, 1. Okay, so we can see from this that you're sort of saying Chrome is going to make a request here. You're less sure about the other browsers. And the answer is no. None of the browsers are going to make a request in this. But it's not actually as mad as it seems. So this doesn't work in HTML5, but it was proposed in XHTML2. So XHTML2 allowed you to do this, put a source attribute on anything, and it would replace the content with what you had in the source. And this was really good because it meant that the alt attribute on images became redundant because you could replace real semantic content. Pretty cool idea, but XHTML2 was backwards incompatible, and it carried with it XML's draconian error handling. And once you invite XML into your home, it XMLs everything. XMLs all over the floor, up the walls. And in the same way that Smurfs stick the word Smurf in front of everything to make it a Smurf thing, XML does it with X. Like you don't want HTML, you want XHTML. You don't want frames, you want X frames. You don't want forms, you want X forms. If you let XML take over your life, it will turn your boyfriend or girlfriend into an ex-boyfriend or girlfriend. And XML's cool with that because you don't need a partner anymore. You've got XML to look after you. It seems fitting that in 2009, XHTML became an X specification, and it was completely abandoned, and no browsers ever implemented that source attribute on elements other than like images and the things they work on now. Okay, but what about this? So here we've got an image element, it's got a source, it's in the page, but I've spelled image incorrectly. I've put it IMAGE rather than IMG. Does the browser treat it as an unknown element, or does it make the request? The browser only has to make the request. It doesn't have to display it on the page, in case you think that matters. XML was too strict to work with the web, but is HTML this lenient, or are the browsers more lenient than the spec? Just get your answers in quickly. I'm going to close the question in 3, 2, 1, and it's closed. So we're kind of edging towards no in all of the browsers. All of the browsers will make a request for this image, and they will display it. Because in the past, a browser decided that IMG is quite difficult for developers to remember, so they should support IMAGE as well. And we've been stuck with it ever since. Which browser engine do you think we've got to thank for this? Yep, you've guessed it. It is Mosaic, back in 1993. The people who invented the image tag, they put this alias in, and a study in 2005 showed that 0.2% of pages were using this misspelled image tag. So any browser that wants to work on the web that we have today has to duplicate this alias. The WhatWG recognized that and they added it to the spec. This is the parsing spec. You know, start tag, name image, change the token to IMG and reprocess it. Don't ask, which is great. But this was actually used in a clever hack recently. Alexi 10 came up with this, which I really liked. You would use this in place of your image elements. And what it does is it loads an SVG for browsers that support SVG, and it loads a PNG for browsers that don't. So the way a modern browser would parse it is it sees SVG and it goes, okay, it's got a width and height of 100%, well, 100 pixels. And it sees this, and it sees this as an SVG image element, because in SVG, images are spelled out full rather than IMG. It's got a width and a height, and I'm going to load this, because this is how you define the source of an image in SVG, because, you know, why have links when you can have X links? So. And then it sees this, and that doesn't mean anything to SVG images, so it's ignored. So we're now showing the SVG image. And older browsers, such as Android 2 or IE8 and below, they will parse it like this. No idea what that is. I'm going to ignore it. I'm going to treat it like an unknown element. Oh, look, the developer has spelled image wrong. It's OK. I'm going to correct it for them. It's 100 by 100. No idea what that means, so I'll ignore that. And then, oh, there's the source of the image. I'm going to download the PNG. So it's kind of nice because it doesn't require JavaScript, and it's a nice way to conditionally load the kind of file that the browser supports. We got quite excited about it, and we were tweeting about it. The mistake we made is we did not test it. So a few of us did just that, and we found out something interesting. All of these browsers support SVG, but which browsers will download the PNG as well? And I'll give you a clue, it's not all of them. Not all of them get it wrong. It's just one or some of the browsers are going to get this wrong. And they'll end up downloading both the PNG and the SVG. I'm going to close the question in 3, 2, 1. OK, so we're saying no in all the browsers, and yes in IE. It's almost like you've been burned by that browser in the past. Well, the answer is you are right. Internet Explorer will make a request for 2 images here. This is because all modern browsers, they've got 2 parsers built into them. It's a relatively new thing for them to have, but they all have it. One parser runs ahead, and it goes and it tries and finds things like it should download, like scripts and images or whatever. And then the other parser comes along and does the heavy lifting, like building the DOM tree, parsing scripts, etc., etc. And this has a really large benefit. A study we did at Google, we looked at 2,000 sites, and when we added this preloader, and we got a 20% speed improvement to get to DOM content loaded. So it's really useful. But in order to be quick, this pre-parser is a little bit stupid. And in Internet Explorer, it's a bit too stupid at the moment. It kind of gets overexcited. It's like, oh, look, I'm going to show this PNG. I'm going to show this PNG. Here I go, showing the PNG. Oh, no, actually, I won't. I can say it's actually an SVG. I'll do that instead. So the main parser sees the markup, and it sees the image, but it misses the SVG context. And then the main parser comes along and goes, well, why am I downloading a PNG? And it cancels that download and goes for the SVG instead. But by that point, it's made the connection. It's probably got all of the image by that point. The moral here is don't trust performance tips. Make sure you test things. At Chrome, we say tools, not rules, which rhymes, so I guess it must be true. But always be on the lookout for existing data or existing tests that you can run. One of my favorite stories in science, or a tale, I don't know how true it is, but it involves this man, August Weismann. And he wanted to disprove that life experience was part of evolution, like something that happened to you during life would be passed down as evolution. So the way he was going to disprove this is he took two mice and he cut their tails off and bred them together. And then he took the offspring there and he cut their tails off and bred them together. And the idea was, like, we shouldn't end up with mice being born without tails, right? And he was running this test for quite a while until one of his colleagues pointed out, it's like, August, you do realize that Jewish people have been inadvertently carrying out this experiment a lot longer than you have. I go, oh yeah. So he stopped his test and he would just use that as evidence. So what about this? We've got a div, it's displaying none, there's an image inside it. So the image won't be displayed, but which browsers are going to download it anyway? So yeah, it's not going to render. So you could say it's a waste of bytes to do so. Or maybe some browsers are going to get it just in preparation, thinking it might be shown. I'm going to close the question in 3, 2, 1. OK, so we're sort of leaning towards yes for every browser. We're quite certain it's going to happen in Internet Explorer. The answer, collectively, you are correct. Yes, all of the browsers here are going to download that image. And this behavior is part of the spec. So in the browser, in the beginning, there is nothing, and then the browser gets sprayed with HTML text, and it will convert that text into a tree of elements that we know as the DOM. When this HTML, when an element is turned into, when a tag is turned into an element, the construction steps for that element are run. And for image, it's really complicated, actually, creating an image element, but step 14 down here at the bottom is where it actually makes the request and requests the image. So visibility doesn't matter at all, it doesn't come into it. And that's kind of good, because it means that your images can download before your CSS is downloaded, before your scripts have downloaded. As a downside, it meant that responsive images polyfills did not work, because by the time your JavaScript gets to the image, it's already started the download of the thing that was there already. You're just going to add a second download by changing the source. This won't be a problem in the future. The resource priority spec, we've specified the postpone attribute, which tells an image that it shouldn't display if it's displaying none, among other things. But what if we are using CSS? What then? So here we've got a div that's displaying none, and inside there's a div with a background image. So it's kind of similar to the image one, but we saw that images are ignoring CSS. But here we're actually in CSS land already. So are there any browsers that are going to download that, or are they just going to ignore it? Because once again, it's not going to be displayed. So you could consider it a waste of bytes. I'm going to close the question in 3, 2, 1. So we're kind of edging towards yes in every browser. I'm afraid not. No browsers are going to download it here, none at all. And that's kind of, I suppose you could see that as a good thing. It's saving bytes. But what if we did this? Similar question. It's a div, display none, and it has a background image. So the difference from the last question is it's all on one element. It's not, the image isn't inside another element that's displaying none. Does that change things? Once again, it's not going to need that background image. I'm going to close the question in 3, 2, 1. So we're edging towards yes in every browser, a little bit more confident in Chrome. Most browsers will, Firefox will not. So what's going on here? So once the browser has this tree of elements, it needs to work out what they look like and where they go on the page. And the first step of this is a style calculation. So it calculates all the styles, it goes through the CSS cascade, the style attributes, the font tags if you're from the 90s, and works out what style applies to each element. But not everything gets its style calculated, so this div up at the top turned out to be displaying none. The browser stops there. It doesn't calculate for the children because those elements have no impact on the rendering of the page, so it shortcuts. So if these elements have a background image, the browser just never finds out about it. This div up at the top here is displaying none, but it did have its style calculated in order to find that out, and that's when the browser will discover the background image. Firefox is a little bit smarter here and avoids the download. But if you change that to, instead of displaying none, you use visibility hidden or opacity 0, Firefox would download as well. Who's getting it right according to the specification? Everyone is. The spec is really vague here. It says the browser may optimize, even if the element is just obscured, it's underneath another one, but no browsers are that smart. This kind of freedom in specifications is kind of good, because it means the browser can do the right thing given the device, the connectivity, maybe even the battery percent, how much battery you've got left. But it's also scary as it means you're going to get the browsers doing different things as they try new stuff with that freedom they have. But I think that kind of diversity is what makes the web great. It's not one company driving forward with its own interests. It's lots of companies driving forward in different directions. And we get this kind of car crash, but with a happy ending. And that's the web that we have today. If you want to avoid downloading a CSS background, hiding the element isn't enough. You need to put it inside an element that is display none. But when you do this, you are just relying on what browsers do today. It's not specified behavior. Browsers may change. The only surefire way is make sure the browser doesn't find out about that background image. Don't add the class name that adds that background, or don't add the element to the DOM at all until you really need it. OK, things have been relatively easy so far because we weren't involving JavaScript. So let's get JavaScript involved. What about this? I'm creating an image. I'm giving it a source. I'm not putting it in the document, and I'm spelling image incorrectly like we did before. So we saw in HTML that it was auto-correcting IMAG to IMG, but does it do the same in the DOM? Do images even download when they're not in the document? Because once again, this is not, the browser doesn't need to render this yet, or it can't render this yet. I'm going to close the question in 3, 2, 1. So this is the point in the quiz where the audience just gets broken and the needles just drift towards the center of like, I don't know what's going on. In this case, most browsers will download, Firefox won't. And there are 2 parts to this explanation. As we saw before, the DOM gets parsed and the creation steps of the elements are run. This animation took me a long time, which is why you've seen it 3 times already, but that is the last time. But when an element's just created using DOM stuff, it's still going to run the creation steps. And we saw for images, at step 14, that is going to be when it downloads the image. We can use this to our advantage, because this one line, you can make a GET request to anything that the machine can access. And in fact, images have their own DOM constructor, unlike a lot of other elements. So that tiny bit of code, instant GET request to anywhere else. And this is pretty much how Google Analytics talks back to the server. But we saw before that Firefox didn't make the request. So what's going on there? When we create this, most browsers, Chrome, Safari, IE, will give us an HTML image element back, whereas Firefox will give us an HTML element. It's not an image. If you add it to the page, it won't display an image. And the interesting thing is here, it's the only one getting it right. We saw before, this is how the browser, how the spec deals with images that are spelled incorrectly, but this is in the parsing spec. And we bypassed parsing by using create element. We're completely bypassing the parser. So it should, well, Firefox gives us an HTML element. It should give us an HTML unknown element, which it does for if you do create element foobar. So Firefox is doing something special for these images, but it's getting it more right than other browsers. I think I preferred it when we were developing for browsers. It was like there was one bad guy, and it was Internet Explorer 6 or 7 or 8, and all the other browsers seemed perfect in comparison. But I see the browserscape as being like an orchestra, where Internet Explorer 8 was just this kid hitting 2 cymbals together and screaming. But once we finally kick the screaming child out of the room, and we come back and we start conducting again, we realize, oh, everyone's actually a little bit out of tune. We just didn't realize because of the screaming cymbal child of Internet Explorer. So let's get CSS involved again, but JavaScript as well. What about this? So I'm creating a div, giving it a background. It's not in the document, but everything's spelled right and valid. We saw images download at this point. But what about when CSS is involved? Are we going to see things download there? Get the answers in quickly. I'm going to close the question in 3, 2, 1. So once again, the needles just drift into the middle. The answer here is no. No browsers will download here. This is the same as the display none case. The browser won't calculate the style of elements that are display none, and it also won't calculate the styles of elements that aren't in the document, because there's no point. It doesn't affect the rendering of the page at all. OK, I'm going to be cruel now. What about this? So same again, I'm adding it to the document, then I'm removing it again. Is it in the document long enough for the browser to go, oh, I should download this background image? Or does it not get to see it long enough? Does it not bother? I'm going to close the question in 3, 2, 1. OK, so we're suggesting yes, because yes, it has entered the document. I'm afraid you were all wrong with that one, or the people who said that. The browser doesn't want to think about styles or layout until the very last moment. And that's normally rendering, when it actually needs to change pixels on the screen. And we can't do that, or we don't do that, while we're in the middle of JavaScript. So the browser actually sits back and waits for that JavaScript block to execute, and then afterwards it will go and look at what's changed and react to that when it needs to render next. But does this change that? So same code again, but in between adding and removing it to the document, I'm going to ask for the text content of the element. Now the text content is going to be an empty string because it is an empty element. But is just accessing that property going to change things? I'm not even assigning it to a variable. So, is it just even going to be optimized away as a bit of JavaScript because it has no impact? I'm going to close the question in 3, 2, 1. Almost dead in the middle. Excellent. The answer is no. No browsers will make a request. Getting the text content is easy. It's just going to go through the DOM, find the text nodes, concatenate their values together. What about this? Similar question, but this time inner HTML rather than text content. Once again, it's going to be an empty string that comes back there because the element is empty. But does it behave differently to text content? Are the browsers going to do something different? I'm going to close the question in 3, 2, 1. So we're saying no here. Yeah, you're mostly right. Internet Explorer will make a download here. And the reason for that is because when Internet Explorer, I don't know. I have absolutely no idea. Some things in the world cannot be explained, and this is one of them. Like how it takes 3 attempts to plug in a USB cable, even though there are only 2 possibilities. Some things cannot be explained. Okay, so on the same theme again, but this time in a text. Once again, like the other 2, this is going to come back as an empty string because it's an empty element. But is that going to behave differently? Is Internet Explorer still going to make the request erroneously like it did before? Is it going to get it correct this time? Who knows? I'm going to close the question in 3, 2, 1. So we're edging towards no. A little bit less sure in Internet Explorer. The answer, yes, most browsers will make a request here. And this actually kind of makes sense in an odd way. Let's make a div. It's got a background image, and it's got some inner HTML. It's got hello world inside it, but world is inside a div of its own. We add it to the document. We ask for its text content. It's hello world. But when we ask for the inner text in IE, Safari, and Chrome, it's going to return this. It's got a line break in the middle. And the reason for this is inner text isn't just the text content. It's more like what you would get if you highlighted the element and copied it. And because of this, it's got like style information because the world is on a different line because the div is block level, or it is by default, and it is in this case. So what actually happens here is the browser, we ask for the text content, it just gets that back. But when you ask for the inner text, the browser has to go, I need to know what the layout of this element is in order to return this. I need to find out if that div's block level, where am I going to put my line breaks? Oh, look, there's a background image there. And then it downloads it because it forces it to look at the styles. Most of the time, the browser will defer looking at styles as late as it can, but here we forced it to happen sooner because we've asked for something that's style dependent. Firefox didn't make a request because it doesn't support inner text. It doesn't support the property at all, so that's just undefined. That was quite cruel. But if we used any of these properties, like outer text, no, not outer text, but offset left, offset parent, Firefox would have made the request as well. Sort of ignorance of that, those elements that will require style information, that's one of the #1 problems with performance that we see on the web. But it's also, you can do some nice hackery with it. I mean, if you look at code like this, it looks really expensive, but it's not. It's really cheap. Because the browser's just going to sit back and watch you just writing this property to an object, and it's not going to care about it until that block ends. And once that's all done, it will just look at the result, and in this case, there's no pixel difference. This can lead to some unexpected results, not just graphical performance. But so imagine, let's have a look at a practical example. Here is Paul Lewis and me, who we work together. We want to go over there. You can tell because we're pointing. But let's do it with code. We're going to say left 0%, we're going to set a transition, and then left 100%. If we run that code, hey, off we go. Excellent, we win at code. But if we run that code again, nothing happens. And the reason nothing happens is the browser's going to batch up these style changes. So we're setting left twice, but the browser's only going to listen to the last one. And we're essentially saying transition to 100%, but we're already at 100%, so it doesn't move. You might have encountered this and tried to fix it with set timeout and an arbitrary number in that. But what you actually want to do is at this point, just after we set the first left, you want the browser to go and look at that style and actually think about it. And we can actually do that by putting one of those properties in, offset width or whatever. And once we do that, we can run that code as many times as we want, and it will work every time. But you are relying on unspecified behavior when you do that. The Web Animations API will save us there. And just before I get kicked off stage, I want to go through the bad side of that. Normally, using things like offset width in the middle of your code can lead to a performance difficulty, and here's an example of that. So here I've got a page with a load of paragraphs, and what I'm going to do is I'm going to set Chrome's timeline recording, which is going to record everything that's going on, resize the screen box, and I'm going to hit that button. When I hit that button, all of these paragraphs are going to become the same size as the green box. So do that, press the button, and they all change. And that was quite slow, and we can see in the timeline there's a little spike there, and if we have a look at the number that comes up there, it's like 1.27 seconds. It's very slow. But there's this little warning icon on there, and if we kind of look into that, we get a clue of what's going on. We get this recalculate style layout happening over and over again, and that's not looking great. The code we're using is really simple. We just loop through all of those paragraphs and set the offset width for the green block to the paragraph. Now, the first time we go through this loop, we ask the browser, what is the size of the green box? And it goes, oh, I know that answer, because I've just drawn it. Here's your answer, easy peasy. And then we set the width to the paragraph. But the next time we come around the loop, we ask the browser, what's the width of the green box? And it's like, I used to know the answer to that question, but since then, you've been playing around with styles on the page. So I need to go away and have a think about what you've changed and see if it affects the width of the green block. And that's going to happen on every loop. This is layout thrashing. This is interleaving style reads and writes, and it's a performance killer. What we actually want to do is just cache that, do the reads first outside the loop, get the green box width, and then go through the loop. And the difference is absolutely astounding. So recording that, changing the width of the green box, click the button, it just happens instantly, and it's a massive difference. And that was like 60 milliseconds all in for everything versus like over a second. So if you need to read something that's style dependent, do it before you start making style changes. And am I out of time? Am I done? Okay, but before we do that, we'll have a look at the final scores and see who managed to win the Chromecast, if I can get a mouse pointer over here. Right. A moment of tension. Where's my mouse pointer? Let's see if this works. Okay. Oh, we've got a draw. That's how many? We've got one Chromecast. We can get another one. That's excellent. I do have a bonus round, but we're definitely out of time. Who's where are these? Where are you two people? Where are you? Oh, one here and there. Oh, congratulations, guys! A round of applause for these guys, actually. And with that, I say thank you very much, and I'm going to make way for someone else. Thank you very much, guys. Cheers.